Alright, welcome back, Generals, to another Let's Fix Generals 0 How to Make the Best Game Ever. So last session we have implemented this function up to this point, and now we wanted to make some adjustment in here because it did not quite work right yet. Let me put let's just run and hit the breakpoint again and then look at it. Yeah. It was some the name is class mismatch class. Yeah, so at the base the class name not matching. Oh, huh? Ah, yeah. That's it. Yeah. Okay, so the problem here is that this class name does not match this here. Yeah. Okay. Okay, how do we deal with that? Behavior module interface. Okay, so I think we are looking at that's a good question. So this was pretty easy here. Just the substring of the old class name size. But now if we cannot use that, then we need a different strategy. What kind of strategy? The problem is searching for the double colon is a double-edged sword, because the double colon can, like, there could be a namespace at the front, there could be a double colon in the parameter list, right? So we need to be careful with this thing. It's not so easy. And there could also be a parameter list. There could also be a parameter, template parameter. How do we do it? The easiest solution obviously would be the best. I don't see an easy solution now, and I don't want to have like a super complicated parsing. So we did previously, we have another function when we do some parsing here. So what was this? Find or create class. So this is only about class. This is not about function name. Yeah, but I mean, class is simpler because, yeah, there can be only one template. Yeah, actually. Yeah, no, actually, hold on. I wonder if this is actually correct as well. Because if you have a template class, and then in the template class you have another template class, then this might not work correctly here, maybe. No. But okay, it did work for our purposes, so we leave it, right? Okay, what do we do here? If we look for the first, I wonder if we can. We could maybe I think we had some other is expected class. Yeah. What did we do here? Limit. 0 limit. Fine. So I was finding the first template argument. I'll find. Why does this work here? Let me put a breakpoint here. Limit is not std string and parse. Let's restore char. I see. std map. Right. I mean, this works for functions, but does it work for the class? Actually, I think this would not work here either if like there was a class here with a template argument at the front, right? Yeah. How about we write a function find or create class by name. Da, 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 da. How about we create a function? So we search from the end and we go okay, fine. How about we create a function get size t, find or scd string and parse or parse. What does this return? Size type. Okay, let's do size t. Find string find class name. Okay, how about we leave this as is for now and we go just to our what we currently implement here. Let's do it for the function first. Okay, find maybe we return. No, the index is good. Find function. Find function name. Okay. And then we give the std string view name. Find function name. Find function name. Find function name begin. begin pos. Find function name begin pos. Okay, and then we do a for size t I equals name dot size -1 I larger than how about we return integer is larger equals -I. Okay. Actually, we can use size t. We simply here use std string view npos, which I think is just, yeah, it's -1 pretty much. Yeah, okay. Okay. So while this is not npos, okay, and then we say if, let's say skip bool skip equals false for if I equals this character, then skip equals true. If I equals that, then skip equals false. If, wait, hold on. How about we say let's say integer int colon count equals 0 int qualifier, I don't know, parenthesis and template, how do we call this, group count, group I don't know how to call it, group count 0. Yeah, okay, so we say if group count is larger than 0, then continue here. Okay, and we say if this is that, then group count, group is a bad name. Okay, and then here we say minus group count, and then here we say if this plus group count, how about we put this here together, if this or that, this or this, there we go. I think that's all we need. Continue, and then here we say if I equals colon, if I equals colon, then we say colon count equals plus colon count, yeah, and then find function name begin pos, and then if we say here if colon count plus plus equals 2, then we break out of this thing. Yeah. And then we have our position. Oh, hold on, we need to move this guy here, there, and then return I plus 2, right? To skip the colon forward again. I think that would be the algorithm. Yeah, and so this function we now put above here, yeah. And then we say here we don't use old class name anymore, I think. Yeah. So we remove this here and this, and remove this, and then we remove this, and then we do make function name sub str 0, no, function name size t, begin pause, function name, okay, and then function name pause, and then we say what do we say? We want to put it in here, append function name. So if we have a pause, like it could also be, hold on, can it return? Yeah, it can return end pause, right? So if it returns, so if so if pause is end pause, this one, then we just take function name. Otherwise, we take function name function name pause, right? Function name dot sub str pause, right? Okay. Maybe we put that on a separate line, const std string view str let's just call it func and we made a mistake. Yeah, there we go. Okay, let's put a breakpoint here and see what this gives us. Okay, so what do we have? This one. Okay, this should be fairly simple. Let's see. Oh, Jesus. Okay, so Name, yeah, is idle. Colon, group count, okay, 0. I is 22, okay. Okay, so this already is suspicious. It should have stepped in here. Why? Oh, I'm stupid. Yeah. Yeah. There we go. Maybe. No, it's fine. Actually, we can probably const char. Yeah, const char. No, just const char c equals name I. Yeah. There we go. Then we can put C and C. There we go. And there we go. And there we go. Okay. Then that makes it a bit simpler. Let's put a breakpoint here. Let's remove this breakpoint here. Okay. All right. So there we go. Okay. So we expect idle, right? Return the position for idle begin. So we have a C, and we'll go in here, group count. There we go. I think we should be able to to continue as well, right? I think it's fine. Just continue here. Okay. Okay. Continue. Well, I mean, it's a bit useless to keep on going there, so I think we can just add a continue here, right? Because there's no point in going on, right? I can keep it compact here. Okay, let's try this. Let's try this trash. Yeah. Okay. There we go. Yes, continue and continue. Okay. Now group count is 0. Where are we? C is idle. It's at the end. Okay. Yeah, very good. Very good. Okay. Okay. Okay, that's the first colon. And we increase this. Actually, could we also on the first colon already? I mean, if we hit the first colon, then I think that's already good enough, right? We don't need to check 2 colons. I think we just need to hit the first colon. There's no way that there's a single colon. Yeah. There won't be a single colon ever. So I think we can simply say colon. We can remove this here. This is simpler. This should work. And then we need to put here this. Actually, hold on. This This is wrong. This is wrong because of this. How about we just say return I plus 1. And here we say return I, or we could also return this here. Yeah, let's make it explicit, this. Yeah. I think this will work. Put a breakpoint. Then it also means that we can put the size t here, actually. It's always good to simplify the code as much as possible. There's probably other ways to make it even simpler maybe here, but I think that's already good. Simple enough. Good, so there we go, there we go, and there we go. And now eventually it will hit the colon. There we go. Colon, return I plus 1. So the pos is 17. And that means the function name is, oh, well, that's not quite right. Ah, there we go. Idle. Yes, that's correct. Yeah. Good. And then it does std string, new class, append func. Yeah. Ah, hold on, but that's incorrect. Pause. Let's do append like this. There we go. Good. Let's try again. Maybe we put a breakpoint here because like this one looks good. Let's just go a couple of times through here and see some examples. All right. So position. And pass function idle, yeah, and now it's sound object idle, yeah, very good. This looks very good. Okay, let's see some examples. Put a breakpoint here, yeah, and we step through some examples. Snapshot CSC. Yeah, snapshots looks good. Yeah. So far, so good. step through a bunch more. That's a lot here. Yeah. My gosh, how many are there? Okay, collide module interface would like to collide with. Yeah, yeah. Okay, it looks this looks very good. Very, very good. Okay. Then I expect that this now runs through. This assert will never hit. That's my expectation, let's say. Yeah, perfect. Perfecto. Perfecto. Okay, how about we take a copy of this guy? Actually, yeah, of both guys maybe. And then we also create a new function here for this thing here, which is, I think, not quite right, right? Because this would fail. This would fail if the class at the front had also template arguments. Then I think this would be wrong. I think that's never the case, but yeah. Let's say find class name begin pos. And we do the same thing. We don't need this, I think. No. No. We need this. And this. And then this. Yeah, I think that would be all. Make class name. Do we need that? Make. Maybe we don't need that. Find class name begin pos. Okay, so my expectation is that we put here this pos. Find class name begin pos. We put name. Yeah. And then we can hide these guys. And then here we would say class name is this. And here parent name is pos -2. Let's check if that is correct. Okay, so we have overwritable, the pos is npos, and so it just goes down here, that's fair. What do we have here? We have another one, that's fair. Oh shit. All right, name, science info. Okay, so far we need to find something that has a okay, how about we put a let's say if name dot find this is not std string npos, then we do int a equals 0 and put a breakpoint in here so we get a faster hit. Yeah, there we go. Okay, so OpenGL color array. So the position is 9. Class name color array and parent name is C OpenGL. Perfect. It works perfectly so far. Well, we only had one case. Okay, this one is pretty much the same case. I don't expect anything going wrong here. Let's see if we get something more complicated, like this one here. Yeah. Okay. Let's see. Parse 5. That looks promising. Yeah, map. There we go. And the parent name is std. Very good. This looks correct. Let's see what else we have here. Clump. Parse 22. Clump. Parent name. Very good. Ah, here we have something more complicated. Yeah. Okay, so this one should return string and parse. Right? And it does. Very good. Very good. Very good. Okay. I think that works. Find class name, begin parse. Yeah. I think that's correct. Let's run it through, see if there are any errors. Good. Okay, then we can remove this garbage here, and we can also remove this, and that's it. I wonder if we should move these together. Yeah. Maybe we should take this and we move it here. And then we take this and then we move it somewhere here to the top, here to the other ones, like this. Yeah. Yeah. Okay, good. Yeah. 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 And okay, so this looks pretty good. I wonder. Yeah, so now the question I have is, with this thing done here, with this function, how many classes, or how many vtables do we have left where we don't know the name for a pure virtual function? That's what I would like to know. So how about we create a for what is this vtable? Vtables. I think we are only interested in the primary vtables, right? So let's remove this here, by the way. How about we just copy this here? This. So if it's smaller than 1, or if it's 0, And then we simply do vtable. I think we're just interested in 0 in the first one, yeah. And basically we want to know here this one here, copy vita entry index entries entry, and then we want to check assert. Well, let's put an if entry dot is pure virtual and entry dot name empty. Yeah, so if we hit this case, then it means we still have pure virtual functions without names assigned. I wonder if that is the case. Right, let's see. It probably is. I suspect it is, but maybe I'm wrong. Right? Because what if there are classes with vtables that have pure virtual functions, but they are never a base class that has an offset? Then that means there won't be any secondary vtables with non-virtual thunks that tell us the name, right? So there only will be primary vtables. So I suspect that with a primary vtable, we would need to try deduce the name of the pure virtual function, which hopefully works. Hopefully. Okay, but we'll see. Okay, so let's see. So is pure virtual false? How about we change this to if entry name empty, then we can put a breakpoint in here. There we go. It's just for testing here for now. Okay, there we go. Pure virtual, and it has a name. Yeah, okay, so that's correct. Let's see the next one. Aha, see? There we have an empty one. What is it? Yeah. Okay. So what class is this? C3D object. Okay. Okay. Then this means we indeed have cases where we are still missing the name. Yeah. Okay. Then we need another strategy on top of the one we already have here to try get the rest. To get the rest, I guess from the primary vtable, right? So here we only use the secondary vtables. Okay, let's keep this down here. Okay, so what I think we need to do is, I think we can actually remove this here, this check, because it's already inclusive in here. And then what we do is we put here the vtable index to 0, yeah, and then we create a new one, and we say vtable index smaller than 1. How about we put this to this, and then we do this, and then we set this to 0, and here we remove it. Yeah, so this one is secondary vtables, and this one is primary vtable. And then here, yeah, we would do different things in here. Okay, what's the time? 50. Okay, how would we do that? I think we can just start copying things and draft it. So we have the vtable, base class, no. Get base class. Get base class. Well, what if we what if we just call it, yeah, it was offset 0, then it should return us the first base class at offset 0. Maybe that works. So we can also put this assert here. Yeah, and then we need to get the base class index, base class type, yeah. And what is this here? Vtable is 0. Oh yeah, okay. Yeah, then it's the same here. But this one is different. I think what we do is, I don't know. Can we do it? And then can we? Yeah, another question is, what is the overlap like? What is the overlap like? Okay, how about we put a breakpoint here and take a look at this a little bit and see what it gives us. Yeah. Oh, okay. Okay, so vtable offset 0, base class, yes. Base class, yeah. Vtables. So this one has 2 destructors. Yeah. Okay, so we have base vtable, and we have this vtable, and they're just destructors. Yeah. Okay, let's look at some other sample. Oh. Oh. What happened? Oh. I see. So this one doesn't have base classes. Yeah, then I see. Okay, if it doesn't have base classes, primary table. I think we can say if base class is not null pointer, then we do this here. All right. Let's put this in here. Okay, so base class, I think we already looked at the first one here. Yeah, that was uninteresting. Science info. Yeah, these are just, let's find one with more here. Okay. Okay, so here we have an idle, and what do we have here? Base. How about we put it in the watch? It's easier to look at. Vtable and base vtable, and then there we go. Make it a bit larger. There we go. Okay, so here it would already work, right? From this one, we see that this one should be the pure virtual, that this one overrides, right? I'm a bit confused though. Didn't we put C sound objects idle here? It can be the case that it's both. It could be set here and it could be set here. Yeah, okay. Yeah. Okay, so this would work. This one would also work. This one, oh, what do we have here? Yeah, this one. So this change would refer to this one, right? Right. 3D object. Yeah, I hope so. 3D object. Yeah, this now object change. So it should be referred to this here. Yeah. Oh, here we got something complicated. Okay, let's take a look at this. So we have a pure virtual. What do we do? What do we do if we have a chain of pure virtual functions? So like in this case, we have this pure virtual here, because it's not overridden in this class, but eventually higher up later on, right? But then it means that here we won't hand over a name to the pure virtual function of this base class that this one has, right? That's why I wanted to previously create those chains, right? Yeah. If I'm not mistaken, yeah, that's a good question. I don't want to make it too complicated. Yeah. I wonder, can there actually be multiple? I wonder, are there actually multiple base classes on offset 0? There must be, right? If you only ever have one inheritance in a class and they are all offset 0, no? Or am I wrong? Oh. Or does it have an offset? It would have an offset, right? Yeah, I think so. Maybe. Wait, let me see. Get base class. So if here we pass in 0, and then base offset 0 minus base offset 0, 0 bigger than this. Yeah, so there must be multiples. There must be multiples with base offset 0. I wonder if there can also be multiples of other offsets then. Maybe. Let's look at here. Type info for update module. There we go. Yeah, so all these at the top there, they're all at offset 0. Yeah. But the others are not. I wonder if there's ever the case where you have like offset 4, 2 of these. But how would that happen? I don't know. Offset 4. I don't know. Maybe that's not possible. Okay, but we can have multiples at offset 0. Yeah. Yeah. Snapshot. So memory pool object, that would be the first actually. Hit the memory pool object should be the first, and then module is the next one, object module next, and then we are and then behavior module, and then we are an update module. I think this is the way, the order we should go. From the one at the lowest and then go up. Yeah, I think so. So let me see. Yeah. So module, yeah, update module, object module behavior. Yeah, I think so, because if we look here in our list, in this list, then we also see, well, we don't see a memory pool object, but there is a pure virtual, and then there's a module, and then there's update module because we override something, and then there is object module, 2 functions, and then behavior module for the most part, and then down here afterwards, this is the first one. This is an after all virtual functions at offset 0, we then put our this is a virtual function that is declared in update module. It's not overriding anything. And then the other ones at the end here, those ones will override something. Yeah. Okay. I see. I understand. Okay, how do we implement that? Yeah. Oh, yes, 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 yes. Yeah. Okay. Yeah, I think we have a plan. Conceptually, I have a plan. We just need to implement it. So I think here with our getBase class function, we probably need to say, so we don't just pass a base offset, but we maybe also need to pass an index where we say, okay, we pass index 0, and then it gives us the first one, so memory pool object, and then index 1 module, index 2 object module, 3 behavior module, 4 nothing, because it's not a base class. Right? And so, yeah. But how would we implement that? How about we go to 7F9080. There we go. Yeah. Yeah. Okay. Yeah. No. How do we implement that? So basically, with index 0, we would have to go to the very bottom of the base class list. Ugh. I mean, that's a bit weird. Or, well, or we go with index 0 is the first one, and then it goes further down. Yeah, maybe that's more logical. No, it is not, because we need to parse a vtable from top to bottom. So we would like to start with the first base class that provides the first functions, right? Yeah. Ugh. What's time? 1 hour 17. It's probably not so hard to implement, but I'm not thinking straight right now. So right now, this function works pretty well for the base class, for all base classes. Yeah, except with a 0 offset, because then it will only return the very first, but not others. Okay. So if we say we would need to count how many base classes there still are, right? And if there are 0 left, then yeah, I think we need a function in the class which tells us the depth of the depth of the base classes at index 0 or at any index, at any offset. Let me think. Maybe only need it for 0, but get base offset depth. Yeah. Yeah. Get base class. No, I think we only get depth. Okay, so we have this function here. Let's add a new function. Let's do uint uint at get base class depth at offset 0. Yeah, and then we put the classes, and that's it. Okay, and so that function oh Jesus, depth 0, yeah, return depth, yeah, and then we do for classes if not base class is empty, yeah, then get base class depth. So if not base class is empty, if not base class is empty, then and we do base class equals base classes 0, yeah, and then classes depth. So here we do depth plus equals 1, and then depth plus equals dot get classes, right? I think that's it, right? So we get a base class. We add a depth here because here we have 1, and then we add the depth of whatever is inside the next one, right? Yeah. Right. I think that works. Yeah, okay, and then in this class, let's create a copy for it. Copy of it and comment this out. So we pass a uint8t index. Let's put this to 0 by default. Yeah. Index. Okay. And then what do we do? So if the base offset is 0, then we would call this here yeah, so here he would say if base offset is 0, and index equals this one here. Index equals that. Then we will call, then we will take this. Wait, if here, if that, there we go. Else that. Base class, there can be multiple base classes at offset 0. Index 0 refers to the bottom. Index 0 refers to the bottom, base class. There can only be one base class at offset larger than 0. Okay. Okay. Okay, let's see. Let's see if that will work. So we need to call we say offset 0. We do 4 int uint 8 ti. That's so base class index equals 0. Base class index plus, yeah. Okay, and then we say simply if base class is null pointer, then we simply break out here. There we go. Otherwise we continue here. Okay, let's stop debugging. Okay, let's put a breakpoint in here. And basically base class index we pass here. There we go. Base class index. Yeah. Okay, and yeah. Yeah. I hope that this helps us properly. Yeah. Yeah, I think so. Maybe. Okay, let's see what this gives. I think I would take a break after we looked at this, as it's time. So base class index 0, yeah. So, where are we? Class type overridable. Well, that one doesn't have base. It does have base class. Okay, let's see what it does. Index 0. So 0 equals 0. 0. What does this do? Depth 0. Base class is 1. So this one is 1. 1. Depth 1. Okay, so then this one should be false. And that means it will go 1 deeper. Yeah. We'll go 1 deeper. And then, oh. Null, null, 0. Well, that doesn't look quite right, doesn't it? What is wrong? Base classes. Oh. Oh. Right. I think I see the problem. I think we are looking at class base class type. Yeah. And then we call this base class classes class. There we go. I think this fixes it. Let's try that again. Okay, so base class memory pool object. There we go. And now this one should actually be a match because it's depth 0 and it doesn't have base classes. It's depth 0 index. There we go. And it takes it, and wonderful. So that's correct. Base class, and then I can do its thing here. And then next one, this one will be null now. Yes. And we are done. Okay, let's see. Let's see if we can get something more. Base class index. Can we? update module. Okay, how about here we say if class type dot mname equals update module, then int a equals 0, put a breakpoint. Yeah, I would like to see it on the big one. Yeah. Yeah, maybe. It was called update module, no? Yeah. Okay, looks like we deadlocked somewhere. I think it doesn't get out of this loop. That's my impression. Yeah. Okay, looks like we have some bug somewhere. Let me see. Index 14. Well, that's a bit large. 14. Oh. I think we have to pass this index here, but I don't know if that would fix the problem that we are seeing. I don't quite understand right now where this infinite loop comes from. It's very suspicious. Yeah. Wow. Okay. Oh. Get basically. I probably need I think we need two different logics. One for the one at 0 offset and the other one with a base offset. Because we don't want to look into other base classes here. Yeah. Base class, base offset. I think we need to make some change here. Yeah. Yeah. But how about we do that next session? Yeah. So basically we need to probably split it into two functions. we do one code parse with base offset 0 and the other with base offset larger than 0. Yeah, and then yeah. Index. Yeah. Okay. Yeah, okay. We will create the following. We will have get base class and get base class at offset 0. And here we provide this index thingy, and here we remove it. Yeah. And then we will keep this function here. Yeah. And maybe we take this one here, put that here, move it here, like this. Okay. And then this one will be at offset 0. And actually here we could... No, this is fine. This is fine. Okay, and then here we basically only care about the first base class. So here we remove this. And then I would say if not base classes dot empty, then we have base class base class equals base classes 0. No. And then we make assert base class base offset assert 0. All right. And then we can then we say we will move all this here, this, and then we remove this, and we remove this, and we return this, right? Yeah. Break. Maybe, yeah. Break, return. We assign it here. Yeah, then we do return this here, and here we do. Actually, do we actually need that here? We can probably. Could have a go to here. Yeah, let's just put the return here, return like that, and then here. Yeah, I mean, we can just put. Yeah, I think it's fine. Or you put a null pointer down here. That would also work. Or how about we say. How about we say for int base class index 0, base class index smaller than 1, plus this, yeah, and then yeah, we put the index here, and then we can put this here again, and then we can break, right? And then here we can also break, and then we have like the consistent implementation across both, right? So it's more similar, right? Which I think is a bit better. Yeah. Okay. I think this is correct. And then we would now call base class at depth. Okay, here we need to call this one. There we go. And then here we would here get base class at offset 0, and we would put here assert vtable offset equals 0, and base class index, there we go. No, get base class at offset 0, there we go. And hopefully this works. Maybe. Let's see. I would really like to wrap up now, but we keep on going. It's better to like finish a chunk of work and, you know, clear the mind afterwards and not pick up the same thought process in the next day. Oh boy. Oh, that's not good. That's not good. Oh. Oh. This should be int. Let's do size t const size t max base class count equals base classes dot empty 0 0, otherwise 1. Actually, we can make it integer int. There we go. Base class count. That should work. There we go. Let's try this again. Oh, please. Dear God, give me the code. The working code. Okay, we hit this now. This is a good sign. Let's see if we get good results here. There we go. vtable. That's a huge vtable. vtable offset is 0. Yes. Okay, so what do we expect now? We expect the memory whatever thingy. So this is class index 1. Let's go to watch. We're looking at m classes base class index. We're looking at base class m class index memory pool object. Yeah, that's the first one. Yeah. Then next one will be module. Let's double check here. Yeah, memory pool object was the first one. Now it's module. Yeah, here module. Okay, next one will be object module and then behavior module. Object module. Yeah, there it is, object module. And then behavior module. There we go. Perfect. Works correct. And now it should end. Next one should end. Vtable. Actually, this assert can be one higher up. And now it should return null. And it does. Very good. And it breaks out and we're done. Okay, and this assert we can move here. And this works correctly and beautifully, and I love it. This is absolutely perfection. Perfection. Yeah, this is very nice. I think maybe we won't need this function then anymore. Yeah, we'll see. Okay, good. The next session we continue here. We need to do something in here. But we got all the groundwork laid out. So I think this is pretty decent. Yeah. Vtable 1. Is this actually legal here? Why is this? How does this work here? I think we actually need to say if vtable size is 0, then continue, right? Because I don't see that this is legal here, because we start at 0 and it is smaller than 1. So it will go here, but if there's no vtable, then that's illegal here. Right? I didn't crash yet because we didn't actually dereference it. I don't know. It should have crashed. Maybe because there wasn't any class yet that didn't have this. Yeah, okay. Okay, but this should be fair. This should be fair. Okay, I think this is fine. Let's put a space here. Good. Then yeah. Yeah, I think we're done here. We'll take a break. I think that was a good session, 2 hours actually. Look at that. Good. Yeah, we made good progress. It's still not quite done yet here. We still need to process more for the vtables. It's quite a complicated process, I have to say. But we are snailing forward. That's all that matters. Snailing forward. All right, so I will stop recording here. I wish you a great day or night. Until next time, goodbye.